In triangle QRS, point T is on QS with angle QRT equal to angle SRT. Suppose that QT is M, TS is N for some integers M and N with N greater than M, for which N plus M is a multiple of N minus M. Suppose also that the perimeter of triangle QRS is P, and that the number of possible integer values for P is M squared plus 2M minus 1. The value of N minus M is. Let's do some labeling. Let's call this side RQ equal to X and this side RS equal to Y for now. The very first thing is I've got to label this theta and this theta. So immediately, since that line RT cuts that in half into two equal angles, I immediately think of the angle bisector theorem. And that is going to give me as follows: x over m is equal to y over n, directly from the angle bisector theorem, no tricks at all. And then I think I'd like to put the m and the n together, so m over n is equal to x over y. Well, if that is the case, then that's very helpful because I can call x and y in terms of m and n. So x could be some multiple of m, and y could be some multiple of n. As you can see, the k's would cancel, and it would just give me m over n. So y I'm going to refer to as kn, and x I will refer to as km. Now, we are going to use something called the triangle inequality, which I'm sure many of you know. Two sides have to be greater than the third side. So let's see here. I will compare this side and that side. So that's x and y. So x plus y has to be greater than the third side, which is right here, which is m plus n. And instead of putting x's and y's, I'm going to put the km plus the kn values greater than m plus n. Factor out the k and you get m plus n is greater than m plus n, and that basically means that k is greater than 1. Now I will use the triangle inequality again, but this time two different sides. I will compare this plus this to be greater than the third side. So it would be x plus m plus n is greater than y. Well, again, instead of x's, I'll put km plus m plus n, and then instead of the y, I'll put the kn. So this becomes m plus n is greater than kn minus km, and I can factor out a k, and when I do, it will be n minus m, and I'll just bring that into the denominator. So k is greater than n minus m plus n over n minus m. All right, so that's pretty decent, I think. Now let's start talking about the perimeter, which is something they are putting a lot of emphasis on in this question. The perimeter of this triangle, just based on what we have up there, is x plus y plus m plus n. And the perimeter in terms of k's and m's, x is km, y is kn, and then this is m plus n. And I think I can factor out something. I can factor out the k. This will be m plus n. This will be m plus n. Factor out the m plus n, and I get k plus 1. All right, so now let's discuss this. We have some very helpful inequalities up here. The first one tells me that k is greater than 1. So since k is greater than 1, that means that the perimeter must be greater than m plus n times 2, because k is greater than 1, so that has to be greater than 2. So therefore the perimeter has got to be greater than 2 times m plus n. Also, another thing that we know that p is an integer. So since p is an integer, p has to be at least So greater than or equal to this plus 1. So 2 times m plus n plus 1. So for example, if this was whatever, 12, and p is greater than 12, p has to be at least 13. And that's all that is, really. Nothing too complicated. All right. Now let's talk about this inequality. Since k is less than m plus n over n minus m, that means that this can be looked at in a very kind of similar way, that's equal to p. So that means that p is less than m plus n times this. We're going to substitute for that. So it would be m plus n over n minus m, and then don't forget about that plus 1. And in a very similar way, since p is an integer, p has to be less than or equal to m plus n times that m plus n over n minus m plus 1 minus 1. So for example, if this was, say, 14 and p is less than 14, p has to be at least 14 minus 1, which is 13. So that's why we put in that negative 1 there. Okay, well, these two things, this one and this one, give me a range. Combining, it gives me a range that p is between. It's either less than this guy, p m plus n times m plus n over n minus m plus 1 all minus 1, or it's greater than this guy, which is just 2m plus n plus 1. Okay, so for example, let's say the numerical values were 50 and 25, and I asked you, they're all integers. How many values does p have? Well, they're all the integer values from 25 to 50 inclusive. So the total would be, 25, 26, 27, all those guys. And you'd easily calculate that by doing 50 minus 24. So in the same way, if I said, how many integer values are there for that range? It was the same thing. You take this and subtract from it this, and then subtract one more. Exactly how I did there. So the number of values of p would be this guy, which is m plus n times m plus n over n minus m plus 1 minus 1 minus this guy, 2, let's just put it in brackets, m plus n plus 1, and then don't forget to subtract 1. So minus 1. Exactly like I did for this right here. And then they told me that the number of values of p is equal to something. In the question, the number of possible integer values for p is this, m squared plus 2m minus 1. So that m squared plus 2m minus 1 is essentially what this whole thing is equal to. So I'll put it here. M squared plus 2m minus 1. And there you go. This is what we have to now simplify. And there you go. There's a simplification. I don't think you want to hear me go through all of this. That would be very painful. I encourage you to do this on your own, and when you do, you get to this very nice result at the very end. That 0 is equal to m times n minus m minus 4. Well, m and n represent distances, so m obviously cannot be 0. So that means that n minus m minus 4 must be equal to 0. That means n minus m is equal to 4. And that is what they wanted you to figure out, the value of n minus m. It's 4, and therefore the answer to this challenging question is A. In the diagram, two pairs of identical isosceles triangles are cut off of square ABCD, leaving rectangle PQRS. The total area cut off is 200 meters squared. The length of PR in meters is. All right, well, these are isosceles triangles, so I just labeled them. This is X from here to here, A to P. A to S, I'll label X. And since they're identical, this is also going to be X, and Q to C will also be X. And in a very similar way, I will label these guys Y's. All right? Now we are told that the area of that shaded region is 200. So, using my variables, it would be 2 times 1/2 base times height. Correct? For the area of the triangles that I've labeled X. And the Y's would be 2 times 1/2 base times height. And they have told you that is equal to 200. Okay? So if you do the math here, you just get X squared plus Y squared. So we'll leave that alone for now, and we'll come back to it a little bit later. Now they want you to figure out what is the length of PR. So PR, which is from there to there. Correct? Okay. I think I know what to do here. We are going to use again our famous Pythagorean theorem, but this time I'm going to use it on this triangle right here. And that means it'll be X squared plus X squared is equal to PS squared. And then I will use the Pythagorean theorem once more, but this time on this triangle, this little guy. That one gives Y squared plus Y squared is equal to SR squared. Okay? Now, the good news is I've got PS, I've got SR, and I can figure out PR, again, through Pythagoras. And you say, well, how do you know that? Well, because this was a square, so that was a right angle, and this is a rectangle, so that's also a right angle. That's how I know. Okay, so we got our final Pythagorean relationship, which is PS squared plus SR squared is equal to PR squared. Okay, PS we just figured out was 2x squared, and SR we just figured out was 2y squared. PR all squared. Factor out a 2 and we get x squared plus y squared. Now x squared plus y squared we figured out was 200. So substitute that in there. PR all squared. And then that is going to be 400 is equal to PR all squared. And therefore, if you take the square root of both sides, PR is equal to 20. So number 22, the answer is B. The square PQRS has side length 30. As shown, the square is divided into 5 regions of equal area. The value of SU over ST is... Okay, well, let's call from here to here X. Well, all of these have equal area, so that means the area of this triangle is 1/5, right? 1, 2, 3, 4, 5. 1/5 the area of the square. The area of the square is 900, 30 times 30. And that's going to be divided by 5, and that will equal the area of this guy, that triangle, which is 1/2 base times height, x times 30. So this allows us to figure out x pretty quickly here. So this is going to be what? 180 is 15x, so x is 12. Okay, so that's definitely nice to know. Okay, and if you then move your attention to this triangle, and this is TU, 1/2 base, which is TU, times the height, which is again 30, again is equal to 900 over 5. And that basically shows me that TU is 12. So that means this is x also. So that is the first part of the question. Now let's concentrate on what they want, SU over ST. Well, ST, if you use Pythagoras, will be ST squared will be x squared plus 30 squared. And then x we calculated was 12. So sub that in there. So that's going to be 144 plus 900, which is 1044. And then take the square root to get ST. And when you do, you get 32.31. Now, in a very similar way, we can figure out SU using Pythagoras again, but this time on this triangle right here. So this time SU squared will be equal to 2x squared plus 30 squared. So that's going to be 2 times 12, which is 24 squared, plus 900, so 1476. And that's SU squared. So take the square root, and SU will be 38.41 approximately. So now this ratio, SU over ST, can be easily calculated. It's going to be 38.41, all approximate, over 32.31, and that is about 1.189, and that is closest to choice B for number 22. In the diagram, rectangle PQRS is made up of 6 identical squares. Points U, V, W, X, Y, Z are midpoints of the sides of the square as shown. Which of the following triangles has the greatest area? Okay, so we have to just go through this and one by one calculate the areas. There's no other shortcut, unfortunately. Okay, no problem. Let's just keep on going here. So PVU. It's going to be the area of the full square, actually, which is 2 times 2. If I let each of those be 1 in length, I've got to give it something, right? So I call them 1. And then I've got to subtract triangles. I've got to subtract this guy. I've got to subtract this guy. And I've got to subtract this triangle here. And that will give me the area of PVU. So 1/2 base times height. 1/2 3 over 2 times 3 over 2, and minus 1/2 2 times 1/2. And when you do this math, you get 15 over 8. And I'm not going to talk you through every single one because that's not necessary. I mean, you guys understand. PXZ. Okay, well, let's get rid of this guy. We're done with that guy. PXZ is where? PXZ. So P to X and then X to Z. Okay, same sort of story here. But this time I'm going to use this rectangle, this one here. And use that rectangle and subtract these triangles, right? Those triangles. So same story. And that's going to be 3 times 3 over 2 minus 1/2 base times height minus 1/2 base times height minus 1/2 base times height. And when you do this math, it becomes 7 over 4, which is 1.75. Okay, so we're moving right along. Next one, of course, is PVX. So P to V to X. All right, so by now I think you get the hang of it. PVX, as long as you don't make any algebraic mistakes. I think that's where people would get this wrong, is small little algebraic mistakes. Like, 3 times 2 is 6, or 3 times 4 is 6 instead of 12. You know what I mean? Those tiny little mistakes is what can get people. So in a careful way, let's do this one. So that's going to be 2 times 2 minus, of course, same as before, right? Those 3 triangles, we just have to subtract those to get PVX. So this is 1/2 base times height, 1/2 times 2, and then 1/2 3 over 2 times 1/2 minus 1/2 2 times 3 over 2. And when you do this math, you get 13 over 8. and that is 1.625. All right, next one, PYS. Let's get rid of this guy. PYS. Oh, okay, this one is easier. They've taken some pity on us. So this is just 1/2 base times height. And that's going to be 3/2, which is, of course, 1.5. And then the last one, let's get rid of this one, and we got one more left, which is PXW. So where's PXW? That is PXW. Right there. Or sorry, PQW. PQW is right here, actually. So this one right here. Okay, that's an easy one. That's just 1/2 base, which is 3/2 times height, which is 2. And that's going to be 3/2 again, which is 1.5. All right, so after all this, we got to pick the largest one. And the largest of these looks like A, this one, which is PVU, so number 24. The correct answer is A. A lattice point is a point xy in which x and y both are integers. For example, 2, 3 is a lattice point, but 4, 1/3 is not. In the diagram, how many lattice points lie on the perimeter of the triangle? There are several approaches to this question. I'll just do it in the way I like, which is a simple way, is looking at it from the perspective of an equation of a line. So there's going to be 3, right? There's going to be the first line, which is from here to here. Then there's going to be another line from here to here. And then finally the third line. Okay? And then we can add up the lattice points. So the first one, which I can call this line right here, I'll just call that L1 like that. So that first one, L1, let's figure out the equation. And we have 2 points, so I can just plug those 2 points in. 1 and 2, so 2m plus b. And 12 and 21, so 21 is equal to 12m plus b. Subtracting, I get 10m is equal to 20, and therefore m is equal to 2. Substitute back into any of these, and you will get b is equal to minus 3. So the equation for L1 is 2m minus 3. Okay, so we have to make a little table and see what we get for lattice points. Well, we're starting here, so that's the first one, 2 and 1. And we're ending here, so that's the last one, 12 and 21. So we have to go up in terms of integer values. So 3, 4, 5, 6, like that. We're not allowed to use anything other than integers. But we have to figure out how many of these will give y values that are integers. Well, without going through the math, sorry, this should be an x here. Without going through the math for this equation, you will quickly realize that no matter what integer value you put in here for x, y will also be an integer. Okay? So that saves us a lot of time if you can recognize that. So that means all of these will give integer solutions. And how many of them are? There's 11 of those. All right. So in a very similar way, we'll do the same thing for the next line. And the next line will be here. Right there. Between those 2 points. And we can call that L2. So L2, in a very similar way, we'll figure out the equation. Y is equal to mx plus b. Plug in the first one, which will be 17 and 6. So we get 6 is equal to 17m plus b. And plug in that point, you get 21 and 12. So it looks like 21 is equal to 12m plus b. Subtracting, we get minus 15 is equal to 5m. And therefore m is equal to minus 3. Plugging m back into any one of those will solve for b. And if we do, we get b equal to 57. So our equation is basically y is equal to minus 3x plus 57. Okay? So in a very similar way, you make a little table and start with, we're starting with 12 this time, and we're ending at 17. And just like how I discussed in the previous line, if you put any integer value in that equation, y will be an integer. Okay? So that saves us time if you can immediately recognize that. So that means all of these will be integer values for y. So we have 1, 2, 3, 4, 5, 6. So 6 values that are integers. 6 pairs. 6 lattice points, basically. So now finally we turn our attention to the last one, which I will call L3. And in a very similar way, we'll figure that one out. L3, we can use the points 2, 1, and 17, 6 to figure out that equation. And as always, y is equal to mx plus b. And therefore, if we're using 2, 1, it becomes 1 is equal to 2m plus b. And if we're using 17, 6, it becomes 6 is equal to 17m plus b. Solving for this, if we subtract, we get 15m is equal to 5, and therefore m is equal to 1/3. Substituting m equals 1/3 back into any of those equations, and you'll get a b value of also 1/3. So our equation is y is equal to 1/3 x plus 1/3. Now for this, we do the same thing. We make a little table. And we're going from, let's see here, we're going from 2 to 17. Okay? So it's a little bit bigger this time. 2 to 17. But this equation will not hold true the fact that it will be an integer value for every value of x that's an integer, because these are fractions. For 2, when x is 2, we get 1. But for 3, it will be 4/3. And that is not an integer solution. That is not a lattice point. Very quickly, you will notice that y is basically x plus 1/3. So the only way this is going to be an integer is if x plus 1 is divisible by 3. And that happens when x is 5, when x is 8, 11, 14. Correct? So this gives me 1, 2, 3, 4, 5, 6. 6 lattice points. So let's see, how many did I get in total? I got 11, 6, and 6. 11 plus 6 plus 6 is 23. But please take a little bit of time before circling 23 and moving on. Why? Because 23 is not the right answer. You say, well, why? What's the story here? You did everything correctly. I followed everything. Because we are facing a situation called overcounting, which is coming up on math exams more and more. And quite honestly, I myself have had my heart broken because of overcounting. And I take these things very seriously. I don't know how seriously you take them. But when I get a question wrong because I did something silly, it really pains me. And I want you not to make these types of mistakes. So, why did we overcount in this question? Because you can actually probably see it here. Look at that. I don't even have to really illustrate it. Do you see? Immediately, I counted 2 lattice points twice. Where? On each of the corners. that was counted twice, that was counted twice, and that was counted twice. Because, for example, this is going to be on this line, but it's also going to be on that line. See what I mean? That is going to be on this line and that line. And this point 17.6 is going to be on L2 and L3. So those 3 points were counted twice. So I have to subtract those 3 points from my total 23. And if I do, I get 20. And that is the correct answer. So number 24, the answer is C.